Earth has a pollution problem. There are plastics and landfill items, the types of things you might throw out at home, and then there's dangerous industrial waste like nuclear byproducts, biohazards, and chemical toxins. These stifle ecosystems and affect the health of vulnerable communities the world over. So far, the best solution we could come up with for disposing of nuclear waste is burying it deep underground. Not ideal when you consider that the stuff remains dangerously radioactive for tens of thousands of years. So why don't we just strap it to a rocket and blast it into the sun, like launching a missile at a target? Wouldn't that solve all our problems? To begin answering our question, it's actually really hard to crash anything into the sun. Let's take a closer look. Suppose we've gathered together a massive pile of toxic waste destined for the sun. The first thing we'd need to figure out is how to get it into space. Easy, right? We've been launching stuff into space for the better half of a century. To get our trash pack through the atmosphere and out past Earth's orbit, we need to accelerate it to a velocity of 11.2 kilometers per second. This is the speed known as the escape velocity, where the kinetic energy of the payload surpasses Earth's gravitational potential energy. Once free of Earth's orbit, our garbage craft is on course for solar collision, right? Wrong. Once our package escapes Earth's orbit, it's still gravitationally bound to the sun. Put super simply, Earth and everything on it is moving sideways relative to the sun at 30 kilometers per second. Combining this sideways motion with the gravitational pull of the sun is what keeps us locked in an orbit. If the sun were to somehow lose its gravitational pull, we'd fly right past it at 30 kilometers per second and keep going. If we on Earth were to lose our sideways motion, we'd only be influenced by sun's gravity and fall straight into it. So there's hope for our garbage ball yet. How could we lose our sideways motion to make this solar freefall happen? Well, there's two options. The first option is to bring up enough fuel to brake in space. Now, technically speaking, you can't really brake in the vacuum of space, but the next best thing would be to configure our garbage payload's propulsion system to generate thrust opposite to its direction of sideways motion. This cancels out the sideways motion, slowing the spacecraft down and letting the sun's gravity do its thing. Earth orbits the sun at 30 kilometers per second. So to brake a garbage rocket launched from Earth, you need to be able to accelerate 30 kilometers per second in the opposite direction of its movement. Here's where it gets weird. The closer you are to the sun, the harder it is to crash into it. Let me explain. The closer you are to the sun, the faster your orbital velocity. Mercury orbits at a dizzying 48 kilometers per second, while Pluto cruises at a cool 4.7 kilometers per second. The faster your orbital velocity, the more you'll need to decelerate to free fall into the sun. That's why it is actually much more fuel efficient to fly to the outer solar system, decelerate, and free fall into the sun from there. It's not inconceivable to accelerate a spacecraft 30 kilometers per second. NASA's Parker Solar Probe accelerated beyond 176 kilometers per second, making it the fastest man-made spacecraft ever. But this brings us back to the problem of fuel. To make this brake and fall method work, you'd first have to launch your garbage payload into orbit with Earth, then launch the fuel for the journey into orbit. Once both pieces are orbiting Earth, you can fuel up your payload and accelerate it past Earth's orbit into orbit around the sun. Then you'd have to use the remaining fuel to decelerate so that it free falls into the sun. Why not launch both the payload and fuel at the same time, I hear you ask? Well, the problem is, it's simply too much fuel. For context, the Saturn V rocket that took man to the moon needed 2 million liters of fuel just to leave Earth's orbit at 11.2 kilometers per second. A mission like this would require orders of magnitude more fuel. No modern rocket technology would even come close to being able to carry the amount needed for a journey like this. Okay, so scenario 1 is out. What other options have we got? Another way to decelerate in space is with a gravity assist. Usually when we talk about gravity assists, we are thinking of the kind that slingshot the Voyager probes into the outer solar system. However, gravity assists aren't only used to speed probes up, they can also slow them down. If you were to approach a planet from behind, fly in front of it, and exit behind the planet like this, your spacecraft loses energy while the planet gains energy. The Messenger and Bepi-Colombo probes have both successfully used this gravitational assist technique to lose velocity and enter orbit around Mercury. The thing is, this takes a lot of time. Bepi-Colombo was launched in 2018 and will only arrive into orbit around Mercury in 2025. Surprisingly, its path to get there is longer than the distance between Earth and Pluto. This is because, to slow down enough, one gravitational assist won't do. In fact, Bepi-Colombo needs 9 different gravity assists to slow down enough to orbit Mercury. Similarly, crashing our garbage into the Sun is all a game of carefully calculated orbital mechanics. If we don't slow down enough, we'll be stuck in the Sun's orbit. If we slow down too abruptly, we might get caught in another orbit we don't want to be in. Okay, you might be thinking, but Alex, this is all feasible. It's hard, but it's within the realm of possibility. So why don't we just do it? Possible? Yes. Worth the time, effort, risk, and technical challenges? Probably not. Not to be a cynic, but think about what could go wrong. First of all, we're proposing packing a bunch of nuclear waste, biohazards, and plastic onto a rocket and launching it from Earth. A launch failure or explosion could be disastrous, to say the least. Even the world's most successful rocket, the Soyuz, has a 2 to 3% failure rate. I don't know about you, but when nuclear waste is at play, I don't like those odds. Even if the launch goes well, the project itself would be ridiculously expensive. So much so that no sane person would approve the budget. There are far too many other missions on the table that would bring so much more to science and humanity than a garbage disposal mission. And lastly, it would actually be easier, quicker, and cheaper, but still crazy expensive, to shoot our garbage out of the solar system toward interstellar space. It would be less fuel intensive since the acceleration required to escape the Sun's gravitational pull is 42.1 kilometers per second, just a 12.1 kilometers per second acceleration from Earth's orbital speed. So there you have it. We don't shoot garbage into the Sun because it's super hard, super risky, and super expensive. We're probably better off being more conscious about what we consume and how we recycle it. The Earth does not have gravity as strong as you'd feel near the Sun, which is a good thing,